Differential leveling is the process of measuring vertical distances from unknown elevation point to determine elevations of unknown points. The most common methods to determine elevation are through the use of a compensator-type automatic engineering level and level rods, and an electronic digital barcode leveling instrument with barcode rod. A thorough knowledge of leveling principles and proper application of methods and equipments will prevent costly delays and generate the needed results in accuracy. The following are the preferred methods of obtaining elevations in order of preference and accuracy. Firstly, we have differential leveling, which is used to control benchmarks, cross-sections, and point elevations. Next, we also have trigonometric leveling for digital terrain model or DTM and 3D models. Next, we also have indirect leveling, which is done by measuring horizontal distances and vertical angles. We also have three-dimensional coordinates, where both horizontal position and elevation are computed by processing the measurements. Lastly, we also have the GPS survey, which can be done given the appropriate equipment, procedure, and data collection. Next, let's talk about the objectives.
Here are the objectives for the Fieldwork exercise number 4. First, to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing a single setup. Second, to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing multiple setup using turning points. And third, to develop the skills in using leveling instruments. Here are the instruments and accessories to be used in this fieldwork exercise. First, we have the auto level. Second, we have the leveling rod. Third, we have the markers. And lastly, we have the plumb. Here are the procedures for the single setup differential leveling. Number 1. The instructor assigns the location of 2 points marked as A and B, which are intervisible with the instrument setup placed between the points. Number 2. Set up the instrument level on the suitable points, preferable about midpoint of the two designated station A and B by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of the instrument man through tripod leg slacks. Number 3. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Number 4. Take the backsight reading of point A where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or thousandth of meter. Number 5. Rotate the telescope after point B is in sight. Number 6. The rodman transfers the leveling rod at station B and must hold it with plumb bob alongside to maintain verticality of the rod. Number 7. Take the foresight reading of the leveling rod and again, the reading must be done up to the accuracy of a millimeter or thousandth of meter. Number 8. After recording the observed values, compute for the difference of the readings to determine difference in elevation between benchmarks. Number 9. Repeat procedures 1 to 8 for second and third trial. And number 10. Tabulate the data.
Now, let's talk about the procedures of differential leveling with turning points. First step, again, the instructor assigns the location of another 2 points marked as point A and point B. Second, the instrument level shall be set up on the suitable points, preferably about the midpoint of the two designated station A and B by driving the tripod firmly on the ground. The height of the instrument shall be adjusted to the convenient level of the instrument man through tripod leg locks. For the third step, the bubble in the vial of the level shall be checked if it is in the center. If it's not in the center, the screws shall be adjusted by rotating either clockwise or counterclockwise, whatever is needed. Fourth, the backside reading of point A, where the leveling rod is being held vertical with the aid of a plumb bob, must be taken. The reading must be done up to the accuracy of a millimeter or thousandths of a meter. The telescope must then be rotated until the newly established point designated as the turning point can be sighted. It must also be ensured that the turning point should be almost equidistant from the instrument as the first benchmark from the instrument. Next, the rodman must transfer the leveling rod at turning point and must hold it with plumb bob alongside to maintain verticality of the rod. Next, the foresight reading of the turning point where the leveling rod is being held vertical with the aid of a plumb bob must be taken. The reading, as usual, must always be done up to the accuracy of a millimeter or a thousandth of a meter. Next, the instrument must be transferred to another location along the route of benchmark 2, where the first turning point is still visible in the telescope, and follow the same procedures as said in steps 2 to 8 until you reach the second benchmark. Lastly, the data that was gathered must be tabulated.